Alright, another DraftScience video. Yeah, I'm pretty quick after the first one here. I did comments and such and was trying to explain um, chicken before the egg problem here with gravity and the shadow idea. And I figured it out now. And it's funny that it comes up with a word that's used a lot in electromagnetic phenomenon. And the word is induction. So gravity needs to be induced. So the problem I was trying to get to was that if you took something in isolation, a body, and this pressure, these arrows were all equal, the arrows coming out would be all equal. And, you have to account for that. There's just as much coming out as went in, just in the same proportions. So how could something like a shadow be happening? Where was it? How would it manifest? And the thing you have to understand is the function of acceleration. And so acceleration is essentially the induction of velocity, but it's induced in something through force. And so in this circumstance, it's induced through the migration of two things into their realm or something. So something moves into something's sphere of influence or in some significant way. And what's happening is the gravity has to be induced in the sense that some percentage of this bigger body has to be actually moving. So some percentage of its atoms have to absorb directional information. They have to take this direction and convert it to that direction or whatever, but some other, not this way, right? Because that's essentially what's happening. So yes, we're when we're sitting here on the Earth is being moved towards us, but not the whole Earth. Okay, it's just a little piece of the Earth, little bits of the Earth's identity. It's atoms. There's a slight increase in some sort of movement, and that movement we feel is the force that pushes us back up. But it has to be induced into it. So, like I said, I don't have the chicken-egg solution. I just have the idea that the gravity is induced in the sense that you have to. So it's not until we start being accelerated do we start actually blocking gravity. So this low pressure is essentially created by the fact that we start accelerating. And so it's the initiation of acceleration where you actually absorb more arrows going this way and convert them to arrows going that way. Once you start doing that, you start creating the circumstance where you are now creating a shadow. So if I'm converting a bunch of arrows that are going this way into arrows going that way or that way, then I'm creating a negative force in front of me. And so it's not until when you're in a gravitational field, it's not until your gravity is felt, your presence is felt by the thing that's going to shadow, that's going to pull you in. Once it feels it, once it starts absorbing arrows, that's when you feel the gravity, and then you fall in, start moving towards it, and as you move towards it, as you're accelerated, you create more shadow, which again feeds it in the sense that your more shadow is creating more acceleration on it. And it's only because of the density of things, how much mass they have, will decide how much of the velocity, the total pushing together, will happen. Obviously the light body will do all of the accelerating if the weight differences are substantial. Our weight difference to the Earth is huge, so yeah, we do all the moving, the Earth doesn't do any moving. But anyway, that solves my problem, is that I didn't account for that this is a force that doesn't really exist until it's initiated, it's induced, until there's a proximity that feeds it. I mean, it's, yes, gravity in an absolute sense goes forever, but the influence is so minute at forever, you know. But it's still the idea that I don't know which one's the chicken or the egg. You know, the acceleration, it seems obvious. You have to accelerate before you can be creating gravity. You know, before there can be a shadow in front of me, I have to be accelerating in that direction. It's, you know, and for the Earth to have a shadow that I'm going to fall into, it theoretically has to be moving, quote unquote. Parts of it have to be accelerating towards me. And it's just a fact. So even though but it's so big, like I said, that my acceleration of some of the atoms of the Earth isn't enough to change the Earth's velocity as a whole. But it happens, and that's what's creating the lack of gravity, the change in directional information that's being absorbed as the Earth is bubbling up towards me, as I'm being bubbled into it and pushed down to it. And the two are creating a net. Both of us are creating a force out the sides that somehow should be measurable some way, but it only exists as we're accelerating. So you have to actually have manifested velocity before you can actually be expelling the arrows to the side. So it's not only just having acceleration, but it has to be unstopped acceleration. Our acceleration is stopped, therefore there's nothing coming out the side because nothing's moving as a whole, overall. Because there's stuff coming back up that's bending everything back in the upward and down direction. Say if I was creating more arrows going sideways, and the Earth was creating more arrows through me going back up because it's counterbalancing the force coming down, it would just bend all the arrows going sideways back up again. So I wouldn't be revealing any velocity. And I wouldn't be revealing the fact that I'm in a gravitational field being accelerated. So it's only when you sustain a velocity that you would be a velocity in a gravitational field that you would be expelling these extra arrows out your side. And that should be detectable, like in space or something. You know, should be some way to detect that. I don't know how high the velocity would have to be for it to be measurable, but theoretically it should be measurable as some sort of extra static charge or something that takes place when you're in space moving at a velocity. I think it's probably there to be found. So that would be a prediction. When you are actually moving at high velocity, which is being induced by acceleration, so it has to be an induced velocity. That means you have to be accelerating. So when you are accelerating, actually moving, accelerating and actually moving. Like I said, it's just tricky because you can be accelerating and not going anywhere, and that would have a neutral effect. So it has to be acceleration that's uninhibited, which is a velocity created by acceleration. Not a velocity you've already acquired, but one you are having induced in you. So when you're in the state of having your velocity induced, accelerating, you will be expelling some extra gravity out the sides, perpendicular to your velocity. That's my prediction. Alright. So anyway, I'm sorry to make 2 videos in a row. I've been thinking about it for a couple of days. I make the video, and then 20 minutes after I make the video, I say, oh, wait a minute, I didn't think of that. So that explains it. So, good. It's harping on me for a couple of days. I was running this through my head and saying something's missing. And that's it. Induction. It fits with the whole, you put a copper tube and you put a magnet in it, and it goes much slower as it falls through the copper tube, and you put a regular piece of aluminum or something, it goes right through. And that's induction. And it's the same kind of thing that I'm talking about. But anyway, so I'll get to that. I'll get to those examples in some other video. But anyway, I'm just glad I figured that out. So, yay me.